This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Here we have another example where we're asked to solve for theta the equation cos theta is equal to minus 1 over 2, but we're asked to solve it for theta is an element of r, where theta is in radians. So when we're asked for theta is an element of r, this means we need to give our answer as a general solution. Now what does the general solution look like? The general solution looks like theta equals whatever our normal answer is from using cast plus 2n pi, where n is an element of the integers. So initially we begin as normal. We draw our cast circle and we ask where cos is negative, because we have negative 1/2 here, and cos is negative in the second and third quadrants. Next we have to find our reference angle, so that means asking the question, what value of theta is cos theta equal to 1/2 in radians? We find that our reference angle in this case is going to be equal to pi over 3. So in the second quadrant, we're going to be looking at this situation. Our reference angle is here, and our whole angle that we're looking for, theta, is here. So theta is going to be equal to pi minus our reference angle of pi over 3, which is 2 pi over 3. But then what we need to do down here is we have to add on our 2n pi and write that n is an element of the integers. Similarly, in our third quadrant, we have a reference angle here, and our whole angle we are looking for is given here. Our theta in this case will be pi plus our reference angle in this case, which is 4 pi over 3. And again, we must go back and make sure that we add in plus 2n pi to our answer. So the last example we're going to do here is this question here. Solve tan 3 theta equals 1, where theta is between 0 degrees and 360 degrees. So that means answer will be in degrees. But what we need to notice here is that we now have this 3 in front of our theta. So initially we're going to ignore this, but later on this will become very important to the answer of our question. So the first question we ask, again, using our cast, is where is tan positive in this case? So C-A-S-T. We know tan then is going to be positive in this A section and the T section. So that is the first and third quadrants. So we've written here tan is positive in the first and third quadrants. So as I said, we're going to work out our reference angle by ignoring the 3 theta and working out for which value of theta do we have tan theta equal to 1. In that case, theta, our theta reference, is going to be 45 degrees in this case, because we're working in degrees. So then, just as before, once we know our reference angle is 45 degrees, we have to work out what our actual value of theta is in each of our two quadrants. So in the first quadrant, we don't need to do anything. Our angle is just going to be 45 degrees. And in the third quadrant, our angle is 180 degrees plus our 45, which gives an answer of 225 degrees. Now comes the part where this question is different to the previous ones. We have that our angle is 45 degrees, looking at our first answer, which means that 3 times theta, our original question had 3 times theta, is the value that we get. So 3 theta in this case is actually 45 degrees. So what that means is we're going to have to work, there's going to be 3 possible solutions for theta, because we could have 3 different revolutions around our unit circle here. So instead of working between 0 degrees and 360 degrees, if we multiply this by 3, we're going from 0 degrees to 1080 degrees instead. So that's the range where our possible answers could be. So in order to get those answers, we start off with our 45 degrees, and we add to that 360 degrees to get 405 degrees, and to that we add 360 degrees more to get 765 degrees, and if we add 360 to that, we'll get an answer which is bigger than our 1080, so it's outside our range. So these are the 3 values of interest to us in this case. So we have here that 3 theta is equal to 45 degrees, or 405 degrees, or 765 degrees. Dividing by 3 to get just theta on its own on the left, we get the final answer that, in this case, that theta is 15 degrees, or 135 degrees, or 225 degrees. And we'll do the exact same steps for our other angle of 225 degrees. So our angle we worked out for the third quadrant was 225 degrees. So that means 3 times theta is 225 degrees. We do the same process where we start with our 225 degrees, we add 360 degrees to get 585 degrees, and add 360 degrees more to get 945 degrees. And again, if we were to add another 360 degrees, we would be outside this upper bound for our angle theta, so we no longer have any more values that theta could 3 times theta could be. And once again, we get these 3 values, and dividing by 3 again, we get our final 3 values here of 75 degrees, 195 degrees, and 315 degrees. So the last thing we need to do is put all 3 of these answers together and say that our final solution for the values of theta are these 6 values here.